Good evening and welcome to today's Deep Dive into one of the most groundbreaking stories in the world of technology. In a bold leap forward amidst ongoing export restrictions on advanced chips, Chinese scientists have announced what could be a historic milestone: the successful development of the world's first parallel optical computing chip, dubbed Meteor-1, claimed to deliver computing power equivalent to NVIDIA's yet-to-be-released RTX 5090. This innovation marks more than just a workaround to sanctions. It may be the beginning of a new era in high-performance computing. Let's break it down. For years, optical chips have largely remained confined to experimental laboratories, a concept promising high speed but impractical for mainstream deployment. That changes with Meteor-1. According to its developers, the chip boasts a theoretical performance of 2,560 TOPS or trillion operations per second, operating at an optical frequency of 50 GHz. For comparison, NVIDIA's RTX 5090 is projected to hit around 3,352 TOPS, while the current RTX 4090 delivers about 1,321 TOPS. It is worth noting that both NVIDIA chips are currently restricted from being exported to China due to U.S. regulations. Meteor-1's performance is not just competitive, it symbolizes a paradigm shift. Traditional silicon-based chips are beginning to hit physical limits related to heat, quantum interference, and power consumption. In contrast, optical computing offers unprecedented advantages: ultra-high processing speeds, massive bandwidth, and significantly lower energy requirements. But what makes Meteor-1 truly remarkable is not just raw power. It is how that power is achieved. While other leading research institutions, such as TSMC and the California Institute of Technology, focus on increasing matrix sizes or optical frequency, the Chinese team took a different route. They scaled up parallel computing. This means maximizing the number of tasks a chip can handle at once, rather than merely making each task faster. Published in the journal eLight, the team's breakthrough centers on squeezing more than 100 frequency channels into a single optical chip. The result? A 100-fold increase in processing power, without expanding the chip's physical size. Using this architecture, they set a new global benchmark by executing over 100 complex computing tasks simultaneously. As Han Zilin, a member of the team, explains, this breakthrough brings optical computing to a performance cost ratio that finally competes with traditional electronic chips. So who is behind this ambitious project? The Meteor-1 development team is led by Dr. Xi Peng, an MIT PhD with postdoctoral experience at Oxford University, now heading an elite unit at the Shanghai Institute of Optics and Fine Mechanics. Dr. Xi attributes their success to a fully integrated approach within the Chinese Academy of Sciences. The team managed to go from fundamental research to full system integration in record time. What sets Meteor-1 apart, even further, is its entirely self-developed architecture. From the light source chip to the interaction and computational chips, every component was engineered in-house. Perhaps the most impressive innovation is the compact multi-wavelength light source, which replaces hundreds of discrete lasers. This drastically reduces the size, cost, and energy consumption of the entire system, a feat that many global tech giants have yet to achieve. Beyond being a workaround for trade restrictions, Meteor-1 may represent the beginning of a new technological path for artificial intelligence and data-intensive computing. As AI workloads continue to skyrocket, the limitations of traditional chips, even those made by titans like NVIDIA, become more apparent. Dr. Xi believes optical computing is uniquely positioned to fill that gap. We are confident that optical computing can meet the ever-growing demands of AI and unleash a new wave of applications, he stated in a recent briefing. Indeed, this might be more than just a technical achievement. It could signal a turning point, one where computing moves beyond electrons and embraces photons as the next frontier. Thank you for joining us. Stay with us for more updates on how optical computing could reshape the global tech landscape.